Hello everyone. This video is an extension to my previous video, Resultant of Forces Part 1. Which if you have not seen that, please visit that also for continuity. The link to the video is in the description. Thank you. Now we will move on to the concepts for non-concurrent force system. There we will see other than this. So what we have learned so far for the concurrent force system, other than this, we will also need to know a few more things. So let us move on to that. Okay, now let's learn what is a moment of a force. And this is the knowledge that we need to solve problems based on non-concurrent force system. Now, moment of a force is actually nothing but the rotary effect of a force. The rotary effect of a force. Say, for example, you have a point A and there is a lever or a solid a lever or a rod or something like that, and you apply a force in the vertical direction at the end of it, like this. Okay, the length of the lever is say L. Okay, the length of the lever is say L. So now of course if this point is fixed, if I say this point is fixed and this force is applied, when this force acts in the downward direction, what will happen to the lever? What will happen to the lever? The lever will rotate in the clockwise direction. So a vertical straight linear force is causing a rotary effect on the body. Okay, so this rotary effect created by the force is called nothing but the moment of the force. Now, how do we find out the value of this rotary effect, the moment? Okay, and how do we use it in equations? So, moment of a force is given as value of the force multiplied by perpendicular distance between the point or the fixed point and the line of action of the force. So you see, this is the fixed point A and this is the line of action of the force. So the perpendicular distance which is nothing but L, that is what we have here. Okay, so moment is nothing but the value of the force multiplied by the perpendicular distance to the line of action of the force. So this will give you the value of the moment. But how do you describe the rotary effect? That means whether it is clockwise or anti-clockwise. So we have a standard in which normally the standard configuration that we follow for calculation, we say if the moment is clockwise, then we say that the moment is negative, and when the moment is anti-clockwise, we say the moment is positive. So in this case, if we have to completely define the moment, we will say the moment is minus FL, because the moment is clockwise, because this moment is clockwise. Okay, we cannot use the clockwise direction in equation. So to use the clockwise direction in the equation, we represent it by minus sign. Okay, so this is what we call as moment of a force. Now let us understand this thing better. Say for example, if I have another force which is acting like this at an angle theta, say this is another force F1. Okay, in this case this force is also acting at the end of the bar, but the moment of this force F1, moment of the force F1, it will be value of the force, but the distance will not be L. Now you may confuse that both the forces are acting at the same point, corner of the rod, and the rod is rotating about the fixed point A, and the distance between them is L. But the thing is, if you remember, I said the moment is given as value of the force multiplied by the perpendicular distance between the fixed point and the line of action of the force. You see, the line of action of the force is this green line over here. And if I have to find out the perpendicular distance will be this. Let us call it as L1. So in this case, the moment of the force F1 will be F1 into L1, and also since it's acting in the downward direction, so the rod will rotate in the clockwise direction, so it will be a clockwise moment, so will be written as minus F1 into L1. Now we need to find out the value of moment. We need to the value of F1 is given to us, but the value of L1 need to be found out using this triangle. You see there is a triangle here. We know the hypotenuse of this triangle is L, and we know this angle theta also. So using this triangle we can find out the value of L1. That L1 we need to use here to find out the value of moment of F1. So this is what we call as the moment of a force. Now let us understand what is couple of forces. You see, uh, again we take a similar body like the way we had over there in moment. Say there is a bar, a horizontal bar, okay, and say that it has two ends A and B, right? Now what is couple of forces? A couple means to form a couple of forces, you need two forces. You need two forces of the same magnitude F and parallel to each other. That means this force and this force. These two are parallel to each other, equal in value, equal in magnitude, okay, but they are at two different points. So we can understand if there is a bar, a horizontal bar, not fixed at any point, it is just a bar in space, and if I apply two forces, one in the downward direction, one in the upward direction, at two different points on the bar, what will happen is that this bar will rotate in the anti-clockwise direction like this, okay. So so the effect created by two forces equal in magnitude, opposite in direction, and parallel to each other. I'll write it down. Two forces equal in magnitude, opposite in direction, and parallel to each other. That means their line of action. I have shown you what is line of action. This is the line of action. The line of actions are parallel to each other. So when this happens, the body on which these two forces are acting will go through a couple, okay, in the now depending upon if it is now here in this case it is going anti-clockwise. If the direction of the forces are reversed, the couple will rotate in the clockwise direction. In this case the value of the couple is given as F, I mean only one F, only so both the values of the forces are same, so that one value of the force multiplied by perpendicular distance between the line of action of the two forces, that means this distance, the perpendicular distance between the two forces. Say let us call this distance as L, okay, so it will be F into L. This is the perpendicular distance, L is the perpendicular distance between the line of action of both the forces. Again this couple is in the anti-clockwise direction, so this couple will be written as plus F into L. From where this plus comes? It comes from the anti-clockwise direction. If you remember, in case of rotary motion, rotary effect, anti-clockwise is positive, clockwise is negative. Okay, so since it's rotating anti-clockwise, we'll get a plus couple having the value F into L. That is the force of the value of the two forces. Only one of them we will take and multiply it with by the perpendicular distance between the two forces, okay. So that is a couple. Let's talk about force couple system. Now, what's force couple system? We have seen that, say for example, we have a rectangular body of with some dimensions, length and breadth. So there will be number of points on this body, and the four corners of the body will be, say, A, B, C, D. And I have a force F which is acting at point A. Okay. Now, say the situation demands that the force A acting on point A needs to be moved to point D. Okay, for this force acting on point A needs to be moved to point D, but the problem should not change. The effect which this force F is causing on the body ABCD, that effect should not change. It should remain the same. So what do we do? So what we do is, our requirement is that this F should act on D. So we simply take this force F and we apply it on D. And at the same time, to nullify this additional force, we also apply another force F in the opposite direction. So this force and this force, they cancel out each other. So the problem has not changed basically. Now what we do is, if you look at this force here and this force here, these two are forming a couple, right? We just learned what is a couple. So this force and this force together are forming a couple. So what we do, we replace these two forces, we remove them and we replace them by a couple which will be acting in the anti-clockwise direction. Okay, and the value we know how to find out. The value is given as the value of the force multiplied by the perpendicular distance between them, which is L. So we take the same body again, say A, B, C, D, and this force and this force forming a couple. So these two will form a couple and will be represented by a couple acting in the middle of the body. Okay, and the value of that will be F into L, and we are left with, once this force and this force is gone, we are left with only this particular force here. So that force will remain, that force will remain here like this. So what do we have now? So the original requirement that was that this force which was acting at A needs to be shifted at D. So now it is shifted at D. But when we do that, we don't want to change the problem. So this couple is added to the system. Okay, and how do we find out the value of the couple? We simply multiply the force and the perpendicular distance between them, this L, and we get the couple also, the value of the couple. All right, so this is how we shift a force from one point to another, but while doing so we have to add a couple to the system. So this is called as force couple system. So finally we reach the last concept to be taught in resultant of forces, that is the Varignon's theorem. So basically, what is Varignon's theorem? There is a definition in the textbook that you can go and see. But in simple words, Varignon's theorem says that the sum of the moments of all the forces in a non-concurrent force system. So you know that if there is a non-concurrent force system, there will be so many different points on the body, and the forces will be acting on different points on the body. And when we take the summation of the moments of all the forces on that in that system about one single common point on the body, that is equal to the moment of the resultant of all the forces about the same point on the body. Okay, so on paper, if I have to show, what will it be? So say for example, I have a body of dimensions L and length and breadth A, L, and B, and say these are the four corners, and there are different types of forces acting. Say there is force F1, there is force F2 like this. Say maybe here there is a force F3, and say there is a horizontal force F4 like this. So these are or say four forces acting on the system. Okay, so what Varignon's theorem says that you find out moment. Say you first choose a common point on the body. Say I choose a common point. Say point B. This is my common point. Okay, so what I do, I find out moment of F1 about point B. Then I find moment of F2 about point B. Then I find moment of F3 about point B, and I find moment of F4 about point B. Okay, and I sum them up. That will be equal to the moment of the resultant of all the forces about the same point B. This is what we call as Varignon's theorem. This is Varignon's theorem. Okay. So instead of finding out the moment of each of the forces individually, what you can do, you first find out the resultant of the system of forces. Okay, so say you have A, B, C, D, same body with L and B. You find out what is the resultant of all these four forces. Say the resultant is like this, going like this. Okay, you find out the moment of this resultant about point B. So that one moment of this resultant about B will be equal to the summation of moment of all this process. This is called Varignon's theorem. And how do we use this Varignon's theorem? That we'll see in the actual problem. But basically, the use of this Varignon's theorem is to locate the position of the resultant in non-concurrent force system. If you remember, when I explained you the non-concurrent force system, I explained you how to locate the resultant at which point on the body it's acting. That is difficult. That is how, and to do that we use the Varignon's theorem. Okay, so this is where we reach to the last concept on resultant of forces. Now all these concepts, now let us use them to solve problems from university board papers. Okay, so let us solve a few problems and let us see how we use this concept. Thank you. Hello everyone. If you have found my video useful, please like, share and subscribe my video channel. Thank you.